Infectiousness. Here I will be going over two forms, the attack rate and the secondary attack rate. So let's start with let's start with what they both kind of are. Now these both are used in outbreak investigations and are some of the more useful set of measurements, a must-have for any epidemiologist. Now the attack rate first is the proportion of people who become ill with or die from a disease in a population initially free of the disease. It is an instance. It is the number of new cases divided by the total population at risk at the start. Well, wait, again. Isn't that just a risk? Well, yep, you would be right if you said that. Remember at the beginning when I showed the previous table and I had the different names for different things? Well, you'll note that I snuck in attack rate over there. It's very confusing because it's not exactly a rate. It doesn't have to be a rate. That's when how irritating the risk and rate being interchangeable actually is. Anyway, so let's use an example just to make sure you've got it in your head. Cholera, total exposed, new cases, we've got risk per 1 person, risk per 100 persons, and an attack rate, 76 per 100 people. You've already times it by 100, so it's 76%. The attack rate in the population is 76%. That's it. In this population, 76% individuals are likely to contract cholera per 100 people. Yeah. However, this can also be used in food studies to go and find out the highest attack rates per. Let's say you've got a outbreak in a restaurant of some gastrointestinal infection, and you want to know which has the highest attack rate out of all the menu items. So you've got your chicken liver, you've got hamburgers, and you've got salad. So you just do your attack rates there. Total exposed, people who had it. The cases, the people who actually got ill, regardless of whether they got ill with whether they just had the chicken liver or not. But that can go and give you a quick inferral into what is highest risk. So in this case, chicken liver had the highest attack rate of 74%. So you probably should go and check on the chicken liver and try and go and get a culture to go and see if it's got any salmonella or something. Previous to all this, any risky substances immediately, specifically chicken liver pate and stuff like that. Especially if it's made from scratch in a blender, blenders, all the kitchen utensils will be seized on investigation. So, secondary attack rate is a bit different and a little bit more complicated. It's calculated to look at the community versus the household transmission, and calculated from starting at the attack rate, and you need to go and add in the incubation period. So the calculation of it is the number of cases among the contacts of the primary cases divided by the total number of contacts times 100 to give it a percent. Now then, so let's say we have 22 cases of illness. We've got 20 households, 4 individuals per household, so that's 100 people. And we've got a community of 1,200 people. Now, we've got our overall attack rate. The original attack rate is 22 divided by 1,200 times 100. That's 1.8%, or 1.8 per 100 people. That's the attack rate. But what about the secondary attack rate? Now, the next incubation period for this, let's say, again, it's cholera. Cholera is between 12 hours and 5 days, but we're going to go and make it sure it's the 5 days fully. Now, after the 5 days, we've got another 17 new cases. All but one have shared a living space with the original 22 cases. This means we've got all but one. We don't include that one. So 1 minus the 17 new cases, so that's 16. Divided by, we've got 20 households, 4 per household, so that's a total of 80 people here. And we've got our original 22 cases, and we times it by 100. This gives us 28%. A summary of it for infectiousness. The overall attack rate, numbers of new cases divided by the total population. Food-specific attack rates, number of persons who ate a specified food and became ill divided by the total number of persons who ate that food. Secondary attack rate, used to document the difference between community transmission of illness versus transmission of illness in a household, usually as a percentage. This is a good link to a CDC document if you want any further information. So that is infectiousness.